Welcome back to the online course, Data Science. In this video, we will continue the discussion about cluster analysis. For the cluster analysis, we have two kinds of cluster analysis. One is partitional clustering, that we will divide the original data into several non-overlapping subsets. And another is hierarchical clustering. The hierarchical clustering, we will divide the original data into several sets, and the set will contain each other. This kind is traditional hierarchical clustering, so that contain a relationship. Each set will be contained by another set. And this kind is non-traditional hierarchical clustering. Maybe some set will not contained by some set. Okay, so this non-traditional clusters. So in this video, we will introduce the hierarchical clustering. So the hierarchical clustering, how to construct the hierarchical clustering, we will produce a set of nested clusters organized as a hierarchical tree. So we can the hierarchical clustering can be visualized as a dendrogram. The dendrogram is a tree-like diagram that records the sequence of merge or sprites, like this one. So here we must define the number of clusters corresponding to which data set. So here we have the data point 1 and 3, and we consider the data 1 and 3 as one cluster. So we can merge these 2 points as merge these 2 data into one point here. And then we consider the point 5, 2 and 5 as the cluster. So we can merge the data 2 and 5 as one point here. And then data 4 and this cluster, we can consider this as a new cluster. So we can merge this point and data 4 as a new point here. Finally, we can and then we can consider this cluster and this cluster merge as a new cluster here. We give the number cluster 3. So we can merge this point and this point as new point. So finally, this point and these clusters, we can merge the point with this cluster as new point. So we merge this point represent to this clustering, and the data 6 we merge this data 6 with its point as new point. Okay, so the clustering, the hierarchical about the clusters, we can be represented use this hierarchical tree, or sometimes we say a dendrogram. The strength of hierarchical clustering is we do not have to assume any particular number of clusters, and any desired number of clusters can be obtained by cutting the dendrogram at a proper level. They may correspond to meaningful dichotomies. For example, if we have some biological science, some dendrogram can correspond to some revelation tree. Or for example, animal kingdom phylogeny reconstruction control the tree like this style. So two main types of hierarchical clustering is one is agglomerative and another divisive. Okay, so we can discuss the agglomerative agglomerative clustering algorithm. That is, we compute from the proximity matrix, and at first we let each data point be a cluster. Then we repeat the following steps. Okay, merge two clusters, merge two close cluster. Okay, so the close cluster based on the definition of distance. Okay, and we update the proximity matrix. Then merge the two close clusters and update the proximity matrix. Okay, until only one cluster remains. Then stop. Okay, so starting situation, we start with a cluster of individual point in the proximity matrix. So here we have several points, and each point we can consider. We will consider each point a cluster, and we have a proximity matrix. And the intermediate situation, if we merge several after several steps of merging, we have some cluster like this one. So we have in this case we have 5 clusters. Okay, and then we must to merge the two clusters with shortest distance. How to merge it? For example, if we consider this cluster with shortest distance, we will merge it. Okay, and when we merge the cluster, we give a new cluster. Okay, so the question is how to update the proximity matrix. How to update? Okay, so we must define the inter-cluster similarity. Okay, how to define the inter-cluster similarity? The first one, we consider the cluster similarity is the minimum of single link. Okay, so later we can for each cluster we know have a several data point in this cluster. So we just consider distance the two clusters as using the nearest pair. Okay, we can see in this figure the nearest pair is this point in the cluster and the point in this cluster. We measure the distance with these two clusters used in the nearest pair. Okay, so similarity of two clusters is based on the two most similarity closest point in different clusters. So determined by one pair of points. We just consider one pair of points or by one link of the proximity grid. So we just single link. What a single link? The closest pair. Okay, we consider closest pair, and the strength of a mean clustering can be handled non-elliptical shape. The original point like here, and we can cluster these data into clusters correctly. But the limited of a mean method are sensitive to noise and the outer layer. If the original data lacks one, and we use the mean method to measure the similarity about the clusters, we will make the clustering the original point will be clustered into these two clusters. Okay, so we can see this some noise and make some mistake about the clustering. And the second method, we will consider the cluster similarity use max or complete link. So here, the similarity of two clusters is based on the two least similar, okay, most distant point in the different clusters. We must determine by all pair of points in the two clusters. We will find the most distance. Okay, this similar point. And the trend of max method is susceptible to noise and outer layer. So if we use max to consider the cluster like this cluster, like this data, we will make the clustering the data point into these two clusters, and we can see this result is correct. Then compare with the result to use the max mean. But the limitation of max we're trying to break larger clusters. So this is large. In here we can see two clusters. One is very small and the other is large. If we use the limitation max, we will break the large cluster into two clusters. Another is we use group average to measure the cluster similarity. Proximity of two clusters is the average of pair proximity between points in the two clusters. So we will calculate all pair and calculate the average of about the clusters. Hierarchical cluster use group average compromise between single and complete link. The strength of this measurement is less susceptible to noise and outer layer, and the limitation about this for this method bias toward globular clusters. Another method is word method. Okay, the distance of two clusters is how much the sum of square will increase when we merge them. So we want to calculate the sum square increasing. Okay, when we merge these two clusters. So the less susceptible to noise. This kind of method is less susceptible to noise and outer layer, and bias toward globular clusters. So for hierarchical clustering, the problem and the limitations. Once a decision is made to combine two clusters, it cannot be undone. Okay, so we cannot we cannot remove the decision. Once decision has been made, we cannot undo the decision. And no objective function is no objective function is directed minimized. Different schemes have a problem with one or more of the following: sensitivity to noise and outer layer, difficulty handle different size clusters and convex shapes, breaking large clusters. Okay, so different kind of method maybe deal with some drawback about the following. Okay, not a method will deal with all the problem. But for the clustering, which kind of measurement is best choice? You can based on your data, maybe you can try to do some experiment. Try to do some experiment and to select the best one from your experiment result.